Let's go to page 63 and start with number 7. Yes, number 7, you have 60 degrees, and it asks you to find sketch each angle in a standard position. Okay, so if you think about the clock, each number on the clock is 30 degrees. So 60 degrees would be 2 numbers. So you go up 2 numbers, would be right over here. So it's going to be at 1 o'clock position. Okay, so sketch that in the standard position and find the degree measure to the of the 2 nearest angle. One negative and positive, they are coterminal to the given angle. Okay, so you're looking for the coterminal. Coterminal means you're going to get the same position. Means you go around the circle one more time. So if you add 360, then it will give you 420. Okay. So you want a positive and you want a negative. So if you minus 360, it will give you negative 300 degrees. Okay, so those are coterminal. Means if you go around the circle one time, it would be 420. Now if you start at 60, you go backward this way, it would be a negative 300. Okay, number 9, negative 30 degrees. So negative angle means you're going this way. Again, negative 30 degree means you go 1 number, so you're going to be at the 4 o'clock position. Okay. And to get the coterminal, again, if you add 360, you get, so you go around circle 1 time. Actually going this way. So you're going to end up with 330. And if you minus 360, if you go around this way, you get negative 390 degrees. Okay. Okay, number 11 is 18 degrees. Okay, you want to find the radian measure in the exact form and approximate form to 4 significant digits. Okay. So to convert to radian, you have to multiply pi over 180 degrees. Okay, so again, this is your conversion factor. If you want to convert to radian, you put radian on top. And so you go and you can cancel, so it would be 1, and this would be 10. So this will equal to pi over 10. So that would be exact answer. And if you use decimal, okay, you just go and get pi divided by 10 equal. So this will equal to 0.3, and let's see, to 4 significant digits. So it will be 31415, so it will be 42. Okay. Okay, number 13. Okay, 130 degrees. Okay, so again, to convert to radian, you just multiply by pi over 180. And so this will cancel. So this will equal to 13 pi over 18. Okay. And if you want a decimal, okay, you go 13 times pi divided by 18 equal. And so this will equal to 2.2689, so it will be 2.69. Right, so again, 4 significant digits. Okay. Okay, number 15, yeah, 1.6 radian, and you want to find a degree measure, and you want to put into an exact form and approximate form with decimal degree to 4 significant digits. Okay, so to convert to degrees, you multiply by 180 degrees over pi. Okay, and so this way, the exact form means you do not cancel it out. Okay. So you just go 1.6 times 180. Okay, so you're going to get 288 over pi degree. Okay. And if you want to get the 4 significant digits, you just go 288 divided by pi. And so you're going to get 91.67 degrees. Right, again, so follow the instruction. So 4 significant digits. Okay, number 17, you have pi over 60 radian. So convert to degrees, you multiply by 180 degrees over pi. So this will cancel, this will cancel. So this is going to be equal to 3 degrees. And to 4 significant digit would be 3.000 degrees. Right, you have to get 4 digits, right? Okay, number 19, you have negative pi over 6 radian. You want to sketch in a standard position. Okay, so pi over 6 is equal to 30 degrees. So every pi over 6 is one number. So it means you're going backward one number. So you're going to be at 4 o'clock position. Okay, and that's it. Okay, 21. You have negative, number 21, 300 degrees. So this is going to be 10 numbers, okay? So it means you go 3, 6, 9, 10, so it'll be right over here, okay? Or if you, backward, sorry, this way. So it'll be 300, so it'll be right over here. Sorry, going the wrong way. This is negative 300, so positive is going this way. Okay. Okay, so again, this is 90, this is 180, this is 270. So 270, you go another 30. So you're going to end up at 5 o'clock position. So this would be 5 o'clock position. Okay, let's go to the next one. Number 23. Yeah, negative 7 pi over 3 radian. Okay, the standard position. Now, if the number is too big, what you can do is you can add 2 pi to get a coterminal. So if you plus 2 pi, that means it's going to end up, so 2 pi will be equal to 6 pi. So make into common denominator. So it'd be 6 pi over 3. So this becomes negative 1 pi over 3. So you're going this way. So 1 pi over 3 is 2 numbers. Okay, so again, you're going to end up at 5 o'clock position. Okay, number 25. Okay, so use a calculator with the conversion routine from the degree measure. Okay, so 25a. So for all this one, we're just going to do a. So 0.50 rad or radian. To convert, I can just use calculator. To convert into degrees, you just multiply by 180 degrees over pi. Okay, so 0.5 times 180 divided by pi equal, so it'll be 28, and let me see how many. Okay, it didn't say how many decimals, so we can just go and make into 28.65 degrees. Okay, so let's go do the 4 digits. Now, just your 4 significant digits. Okay, 27a, 25 degrees. And you want to find a radian measure. So again, if you want a radian, you put a radian on top. Okay. And so 25 times pi divided by 180. And so this will equal to, I'm going to go down. Be 0.4363 radian. Okay. Okay. Number 29a. Okay. if the radius of the circle, so r equal to 5.0 meters, find the radian measure and the degree measure of the angle subtend. So you're looking for theta. Okay. And for A, the arc length, so S equal to 2 meters. Okay. So you can first write down the formula. So S equal to 2 pi r times by theta over 360. Okay. And so just substitute. So 2 equal to 2 pi r is 5 times by theta over 360 degree. Okay, so we just go ahead and first multiply by 360 on both sides. So cancel the denominator. Then after that, we're going to divide by 10 pi on both sides to cancel out this. So this will cancel out. So theta equal to, this will cancel out. So theta will equal to 360 over pi. Okay, so theta will equal to 114.6 degrees. Okay. And to get a radian measure, we already know that theta equal to 360 degrees over pi, right? So to convert this into radian, you have to multiply by pi over 180 degrees. So this cancel out, this cancel. So theta equal to 2 radian. Okay. Okay, number 31A. Okay, so same thing. The circle with radius of 7 meters. Find the length of the arc. So you're looking for S. Okay, with the angle, so theta equal to 1.35 radian. Okay, so you can start with your formula. S equal to 2 pi r times by okay, I'm going to find the radian first. So theta over 2 pi. Okay. And the reason I'm using radian first because there's a 2 pi of it, so it's easier to get. Okay, then you substitute. So S equal to this is going to cancel out. So equal to r times theta, so it'd be 7 times 1.35. So S will equal to 7 times 1.35 equal 9.45 meters. Okay. Okay. So again, if this giving in a radian, you want to use a radian. Okay. So that way things get canceled out. Okay. The long way is you convert this to degree and use the degree, but that's kind of the long way, so you don't want to do that. Okay, let's go to the next one. Okay, number 37A. A circle with radius of r equal to 12.0 centimeters. Find the area of the sector, so you're looking for area of the sector with the central angle, so theta equal to 2.00 radian. Okay, so this is finding the area of the sector. So first write down your formula. So area equal to pi r squared. So this is the entire circle. But you don't want the entire circle, you just want the part of it. So the part that you want would be 2.00 over 2 pi. Okay? So you want a 2 radian out of the total 2 pi. Okay, again, because this is radian, so you have to use 2 pi. If it's degree, you have to use 360. Okay, so let's go and substitute everything in there. So area equal to pi cancel out, and the 2 cancel out, So it'll be just r squared, so it'll be just 12 squared. So area equal to 144 centimeters squared. Okay. Okay, number 41. Okay, indicate the quadrant in which the terminal side of each angle lies. Okay, so 495 degrees, you're looking for what quadrant is this? Now, if the angle is too big, what you do is you go around a circle, so it depends on the number. So I'm going to unwind the circle, so minus 360, right? I'm going to unwind one circle. So this will give you 135 degrees. So 135 would be right over here. So that's quadrant 2. Okay. Okay, number 43. Negative 17 pi over 6. Okay, so again, the number is kind of big, so I'm gonna add 2 pi. Okay, I'm gonna go around the circle one time. So this becomes negative 17 pi over 6 plus, again, get your common denominator first. So you have to multiply by 6, so it'll be 12 pi. And so this will equal to negative 5 pi over 6. Okay, so every pi over 6 is one number on the clock. So there are 5 of them. So you start at 3 and you go 5, you end up with 8 o'clock. Okay, so you can end up right up here because negative is going this way. So you're going to end up at the 8 o'clock position. So this is quadrant 3. Okay. Okay, number 45. Negative 937 degrees. So this is really big. So I'm going to go around the circle twice. So I'm going to add 720. Right? Every time we go around the circle, it's 360 this way. So I'm going to go around the circle twice. It will be 720. So when you add, you're going to get negative 217. Okay. Now it's negative. So over here it's going to be negative 90, negative 180. Negative 270, so negative 217 is about right over here, okay, and so this is going to be quadrant 2. Okay, and next one, 47. You got 29 pi over 4. This time I'm going to plus, let's see, I'm going to plus 6 pi. I'm going to go minus 6 pi. I'm going to go around the circle 3 times. Okay? And let's see how it come out. So going around the circle 3 times. So this is going to equal to 29 pi over 4 minus 4. I get your common denominator, and this would be times by 4 would be 24 pi over 4. And this would give me 5 pi over 4. Okay. So again, what I'm doing is I'm looking for the coterminal. So start over here, positive. Each pi over 4 is half of the quadrant. So 5 would be 1, 2, 3, 4, 5. It's going to be right over here. So it's going to be quadrant 3. Okay. Okay, next one. Okay, 10 radian. Okay, so remember every circle. So this one is going to be a bit tricky. So here's 0, pi over 2, pi, negative 3 pi over 2, 2 pi. Now 2 pi is about 6.28, okay, because 1 pi is 3.14, right? And so over here the 3 pi, so if you go around the 3 pi, let's go and get calculator, see where the things is. Okay? So let's see, 3 pi is going to give you, so 3 times pi equal, so 3 pi equal to 9.42 radian. So 10 radian is going to be a little bit more, so about like right over here. Okay. So this is going to be in quadrant 3. Okay, next one, number 51. Say find each value to the 4 decimal places. Convert radian to decimal degree. Okay, convert. Okay, so basically I want you to convert degree into radian or radian into degrees. Okay. Okay, so number 51, you got 56.1225 degrees, and you want to figure out how many equal to how many radian. Okay, so you can convert to radian. You have to times by pi over 180 degrees. Okay. Okay, so 56.1225 times pi divided by 180 equal, and so 4 decimal places. So this is equal to 0.9795 radian. Okay. Okay, 53. You got 0.4638 radian, and convert to degree. Okay, so you need to multiply, convert to degrees, you multiply by degree 180 over pi. Okay, okay, so 0.4638 times by 180 divided by pi equal okay, so decimal degree, so this will be 26.57 degrees. Okay, there are more digits, but running up to the 4 decimal places. Okay, 55. Okay, you got 87 degrees, 39 minutes, 42 seconds. So what will this equal to? Okay, so again, you have to times it by, so when you convert to radian, you have to put radian over 180 degrees. Okay, so over here, so to use calculator, you have to enter 87.3942 and convert to decimal degree first. Okay, so once you get decimal degree, then you go and multiply by pi, divide by 180 equal, and so this will equal to 1.52998, and you want the 4 decimal places, so you have to chop it off, so this will become 1.530. So this is a little bit tricky to run it off. Okay. Okay. Next one, yeah, 19 pi over 7, and so this will equal to how many degrees? So again, to convert into degrees, you multiply by whatever you're going to convert, that's what you're going to put on the top. So if you're going to convert to degree, you put a degree on top. Okay, okay, so the pi will cancel out. Okay, so you got 19 times 180 divided by 7 equal, okay, so you got 488.6 degrees.